I won't touch it.
Okay. Our topic for today will be on EKG analysis. I think if we have time, then we'll discuss on rhythm interpretation. Okay, so when we analyze the rhythm, first let's see how like the normal EKG tracing looks like. Okay, so if you have if you have this one, so always when we analyze the EKG, we need to see like three things. One is the waves. Two will be what? Segments. And three will be intervals. These are the three things that we see on the EKG. Okay. So what are the waves? The waves are always they are depicted, okay, by the one that are going up or down. Okay. So if you see here on the tracing, there is what a straight line that's going like this. Can you see? This is called zero line, or it's an isoelectric line. Okay, this is a zero line. It means there is no any electrical activity, or it's isoelectric line. Okay, so anything that's going like up is an upward deflection, or it's also proportional. And anything that's going down, okay, that will be downward deflection, or that's a negative deflection. Okay? So you can see from this line, there are waves that are going what? Up, like P wave. This is P. And this one is what? R wave. This is what? T wave. So this wave, they go what? Up. Okay? And if you see this one and this one, Q and S, okay, they go up, down. So these are called the waves. Okay, so these are the first things that we need to see on the EKG.
That's the waves, you said? Waves?
Yes, these are waves. Like, okay, then are segments. So segments are the lines that are between the waves. Okay. So if you see, for example, this line is between P wave and between Q and R waves. Yeah. So that is called ST segment. So P waves are like what? P wave, Q, R, S, and T wave. So sometimes there is what we call U wave, that you see it in some conditions like in hypokalemia. Okay. U wave, you can see it in hypokalemia. What do you mean by hypokalemia? Hypokalemia means a low potassium level. Okay, it's a low potassium level. When there is a low potassium level. So the segments here, we can see these ones. So which segments do we see? So we have one segment here. Okay, that is called the PR segment. So PR segment. And we have here ST segment. So these are two most important segments that you can see here. Okay. Then intervals are waves plus the segments. So when the waves and segments they come together, they are what? They are intervals. Okay. So which are the waves? EQRST. Yes. Plus the segments. So if we take this P wave and this PR segment, so the whole thing from beginning of P to the beginning of Q, this is called PR interval. Which we call PRI. Okay, so PR interval is from the beginning of what? P wave to the beginning of.
Between segments, why we don't call like PQ segment?
Huh? Yeah, it's a terminology. In the American system it says PR, the British system they say PQ.
Ah, okay.
So it's just terminology difference.
Okay.
So PR interval, okay? And here we have from the beginning of Q to the end of S, we have QRS, which is usually termed as QRS complex. Okay, and then we have from the ST to, the ST from the beginning of this line in the ST segment to the end of T wave, which is called ST interval. And we have what we call QT interval from the beginning of Q to the end of T, which is QT interval. Okay, so these are basically three things that we need to see on the EKG: waves, segments, and intervals. Now, after we see this one, so which things are we going to see when we do the analysis? Okay, so in analysis, we do mainly 5 to 6 things here. 1, we do what? The rhythm. 2, we do what? Red. 3, we do what? P wave. 4, we do PR interval. 5, we do QRS. And 6, we do the QT interval. All together with the QT, there is also what's called QTC, which is the correct QT. So let's do the rhythm. So 1, let's do the rhythm. So what do you mean by rhythm? So rhythm is the spacing, okay, that's coming between the different waves. So according to this, we can calculate 2 kinds of rhythms. 1 is ventricular, 2 is atria. Okay, so if we say again our EKG, yes, so ventricular rhythm, okay, we can analyze it by checking the RR interval. It means we have these R waves here. So the R waves, okay, it means the distance, okay, the gap between this R and R, the interval between these tells us the rhythm. So if the interval between R and R is the same all over your strip, then that is what? It means it's a regular rhythm. But if it's not equidistant and the distance, the interval is not like the same, and there is a difference, that will be irregular. The rhythm is irregular. Okay, so we have ventricular, it can be the regular or irregular. Atria, we do P to P, from this P to the other P. Okay? So, this is also what? P, P, it can be what? Regular or irregular. Okay? Now let's define some of the terms here, or the waves, okay? So we have P wave here, we have Q, we have R, we have S, and we have T wave. Okay? What do you mean by P wave? Okay? P wave. So always, P wave tells us about what? Atrial depolarization, or it shows that the atria is what? Getting the impulse and the atria is contracting. Okay? So if we see our heart here, so you can see, okay? So you can see the atria is here, yes? So in the atria, okay, there is what? S and O. So if we see our heart, SA node here, we have AB node here, we have bundle of his, right and left bundle branch, and we have the Purkinje fibers. Okay, so what's this one? This is the right atrium, left atrium, right ventricle, left ventricle. Yes, that's what when we see the heart. Yes, so we have 5 electrical pathways that are very important for the transmission of the electrical impulse in the heart. So one is SA node, which is found in the right atrium. SA node. So that is also called as the pacemaker. The pacemaker. Okay. Then the next will be AV node. Okay. Then this is what the bundle of his. And these two, these are the right and left bundle branch. And we have the Purkinje fibers finally. That goes to the whole of the ventricles. Yes? So, electrical impulse that we starting at the SA node, it first goes to the right and left atrium. So it goes to the left atrium through what we call this bundle here. Okay, that is what we call Bachmann's bundle. And then it goes with 3 internodal fibers. 3 internodal fibers to the AV node. Okay, so 3 internodal fibers, they take it to the AV node. Bachmann's bundle, take it to the left atrium. And then from the AV node, it goes through the bundle of his, and it goes to the right and left bundle branch, then to the Purkinje fiber. Okay? Right and the left bundle branch has 2 fascicles, like the anterior one, that goes on the anterior or the front surface of the ventricles, and the posterior. So there are 2 fascicles, anterior and posterior fascicles. Okay? So what does P wave show? P wave shows us when the impulse is coming from where? From the SA node, and then both atria, they receive that impulse and they what? Contract. Okay? That is what we call atrial depolarization. So that is depicted by P wave. That's depicted by P wave.
What is the time delay between the SA node electrical shock and the contraction of the heart?
Yeah, usually everything, all this time, okay, after this one is done, there is a 0.1 second delay in the AV node. Okay, so this is like what? Atrial depolarization or is contraction? Atrial contraction. So the atria contracts. Then next will be what? It goes to the ventricles. So the ventricles will depolarize. Yes? And that's depicted by QRS. So QRS is what? Ventricular. Ventricular depolarization, or that is contraction. Then P wave is the opposite. Rather than depolarization, it will be repolarization. Ventricular repolarization, or which means relaxation. That means the ventricles, they relax. Okay, that's called repolarization. So that is what disturbance depict, PQRST. So after the rhythm, then you need to analyze what? The red. Okay? So we said that we have 2 kinds of, it can be regular or irregular. So if the rhythm is regular or regular rhythm, you use what kind of method? The 1500 method. Okay? For irregular rhythm, you use what? 6 second method. Okay. So what do you mean by 1500 meter? 1500 meter means you count what? The number of little boxes. Okay, between RR, where you do ventricular, and between PP, where you do atrial webs, and then divide through what? 1500. So a rate can be what? It can be ventricular, or it can be atrial. Right. So when you do ventricular rate, then take the little space between RR or ventricular. When you do atrial, do what? The PP. Yes. Now let's say here you have from here to here. How many? Let's say you have 1, 2. Let's say you have, okay, this, and how many little boxes do you have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 15, 16, 17, 18. Okay, let's say 18 little boxes. So it means always you have how many? 5 little boxes will be there to get 1, 2, 3, 4, 5. So 5 by 5 will be how many boxes? 1 big box. Okay, so the 5 little box, 1, 2, 3, 4, 1, 2, 3, 4, 5. Okay, will be 1 big box. Then another 5, another 5. Okay. So now how many do we have? 18. Yes. So what do? We divide 1500 by 18. We have a nice calculator. Do that for me. So it will be how much?
Yeah. 1500 divided
By 18.
83.3.
So 83. Okay, 83 is per minute. Will be the heart rate. Yes. So you got the heart rate. That's the ventricular rate. If you want the atrial rate, take the box between P and P. Basically, if it is like a normal rhythm, then it will be the same as the R and the R. It will be the same as the ventricular rate. But if it is a different rhythm, especially then if there is any atrial rhythm, then it will be different. So that is how we do rhythm, and rate. Yes.
So for a 6-second method, what is it?
Oh yeah, it's a good question, yes. 6-second meter means in your EKG strip, take a 6-second gap, okay? So that will be like this. You have the EKG strip, let's say, okay? And on top there is a 1 second gap, like small lines that are 1 second each. So this 1 second, 2, 3, 4, 5, 6. So you take the 6-second strip, okay? And then count how many, what? QRS or R in between your strip, okay? For example, in this case, okay. Now in this case, how many QR or how many R waves do you have? So that we need to get from here up to what? Here, yes? So do we include this one? No, okay. So what we do will be count 1, 2, 3, 4, 5, 6. So what you do will be 6 multiplied by 10, and you will get 60 per minute. That is called a 6-second method.
This is for irregular rhythm.
Usually we use this one for irregular. So when it's irregular rhythm, then you use 600. When it's a regular rhythm, then you use the 1500 method. Okay, next, P-wave. P-wave. So there are some criteria that we follow for P-waves. Okay, so P-wave, it should be 1, upright. It means we say that we have some waves that are up or down. So always if a P wave is up, then that is what? Upright. Okay? 2, P wave should be what? Symmetrical. And round. It should be round like this. It should be round like this. For example, this kind of P wave, is that normal? No, because it's not round. This is called notched. This is called notched P wave.
So what about a slight arch?
Huh?
What about a slight arch?
Like, can you
Like a
draw it?
little-
Like this one?
You're talking about this?
Okay?
Same mark.
I don't know. It ain't round, but I don't want to stop.
That.
Yeah, this is T wave. This is T.
Oh,
It's no P.
so
The P
there,
is this one.
that one.
So that's round. That's
Right
round.
there too.
It's round. So, no, or if the P wave is inverted like this, it's not also normal.
So if the P wave is not upright or
If it's not
symmetrical,
symmetrical,
it means something
if one of
wrong.
this is missing, then there is problem on P wave. It means there is problem either on the SA node or on the Atria. So the other parameter is there should be one P wave for each QR rays. It means if you see they are coupled, P wave, QR rays, P, QR rays, P, QR rays, P, all your rhythm should be one P wave, one QR ray, not missing. If there is a missing P wave for QR rays, then there is a problem. Okay, so these are the 4 parameters that we need to follow for P wave. P wave should be upright, should be round, and should be one P wave for each QR rays. Then if such kind of P wave, how do we call it? Is a normal P wave. So if it is not like one of these, it's abnormal. So we need to find what's the abnormality. Then the next will be PR interval. So PR interval is, the interval between the beginning of P, so you cannot put this P wave, to the beginning of Q wave. Okay, beginning of P to beginning of Q. Then count what? The little boxes. And how many boxes you have? Multiply by 0.04. Why? Because each little box is how many seconds? 0.04. So one little box is 0.04 seconds. So let's say I got 4 little boxes here. 4 multiplied by what? So I got what? 0.16. Okay, 0.16 seconds. So usually the normal range will be 3 to 5 little boxes, or which will be 0.12 to 0.20 seconds.
So the machine don't tell us none of this?
Yeah, it will tell you, but you need to know something as a technician. Okay? That's called PR. Because PR interval is very important, especially to tell us something about AV node here. Because AV node is an important node. AV node is very important for what's called physiological delay. It means it brings what? A physiological delay. Because the electrical impulse is what? Delayed on the AV node for a while before it goes to the ventricles. Yes? So it creates a physiological. Without this physiological delay, there is no heartbeat, there is no even life, there is no circulation, there is no blood pumping.
So what is physical?
Yeah, I think that one is a delay. That is, let's say the impulse is being released at SA node, then it goes to the AV node and it will be held for like few seconds before it's being released. That is not like immediately released to the.
AV node is it like a backup for SA node?
Yeah, for SA node, if the SA node is not working, AV node will take the place.
But if SA node is working properly, AV node is not.
Yeah, AV node just will take the impulse from the SA node. Otherwise, if SA node is not working, then LV node will send impulse both to the ventricles and to this SA node. Both SA node and ventricles. I think maybe we'll discuss that one in the interpretation. Then QRS. QRS. So we say that QRS shows us what something on the ventricles, yes? That is, it shows on what's QRS, the polarization of the ventricles. Yes? So what we do will be bring or count the little boxes from the beginning of Q to the end of S. Okay, from the beginning of Q to the end of S. So how many little boxes are there? So usually the normal little box should be 1 to 2.5 little boxes. So which is about 0.04 to 0.10 seconds. So what do? We multiply the little boxes with what? Again with 0.04. Okay? Because each millimeter on our EKG, let's say this is 1 millimeter by 1 millimeter, this is 1 millimeter, this is 1 millimeter. So horizontal shows us time, okay? And vertical shows us the voltage. Okay? So the time will be in what? In millisecond or second. Voltage will be in millivolt. Okay? So each horizontal 1 millimeter is how many seconds? 0.04. So this is 0.04. And each vertical height 1 millimeter is how many millivolts? 0.1. So 0.1. So each little box is 0.04 by 0.1. In another words, okay? Or 1 millimeter by 1 millimeter. But when we change it, it's 0.04 by 0.1. So we need to multiply each little box by 0.04 second. Okay, so that's why here we multiply each little boxes for QRS and multiply by 0.04, the normal value 0.04 to 0.10. Then the next will be QT interval. QT is usually the largest interval. So you come from the beginning of Q to the end of what? T. Okay, so usually QT is very important. Why? Why? Because there is what we call prolonged QT syndrome. Okay, sometimes it's congenital. There is congenital prolonged QT syndrome, especially in babies, in children. Okay, so that's also very important for that. So, okay, what do? You count the little boxes between Q and T, okay? And then count and then multiply by what? By 0.0 for the same, okay? So usually that's the longest interval we have. So, to get the QT, which is the corrected QT, so what I recommend is that go to online what's called Bases formula or QT, corrected QT. What you do will be you enter the heart rate, okay, and enter. So when you get the heart rate, the rate here, yes, the one that you calculate here. Okay, 83, let's say, and enter the value of your QT here on 6. Let's say it's 380. Okay, but always the QT, if you got it in second, you need to change it to millisecond by multiplying by what? Second by 1,000. Okay, you need to change it to millisecond because that's in milliseconds.
Say it one more time.
If you calculate the QT in seconds, you need to change it to millisecond by multiplying by 1,000. Okay, so here is 83. This one is what? 380. Then you click it, and then you get the QTC value. Or like otherwise, usually the formula is what we call the square root of, okay, QT divided by the okay, like by R and R. Square root of R and R. It's like the Brazil formula is QT divided by the square root of R and R. It's called QTC. QT, the QT that, okay? So you can also use this formula. You can go to R and take the R and R, take the square root of that, divide by QT, you get the correct QT. But here, the online calculator gives us.
So Doctor, one more time, why QT is very important for us?
Yeah, here, one, if there is any prolongation of the QT interval, especially in babies in children, there is what we call congenital prolonged QT syndrome. From birth, they have prolonged QT. Okay, let's say the normal QT is like this, yes, but the abnormal, the prolonged QT will be like this. Can you see? Here, QT is normal, okay? This one is what? Prolonged. It's called prolonged QT syndrome. Okay?
So what is the reason? What caused that?
Yeah, usually there is what we call, it's also related with Torsades syndrome, or Torsades, Torsades is a ventricular rhythm, where the ventricles are really like in tachycardia, or like very fast. The ventricles are beating very fast, and it's also related with that. It's called Torsades de Pointes. It's a kind of, usually the wave, we'll discuss on rhythm interpretation, usually it's like irregular beats, like irregular waves are coming. Like this. Okay? Okay, any question? Okay, let's take a break and